Today we discuss about hydride transfer reaction. Listen carefully. Today we discuss about number 4, that is known as hydride transfer reaction. What is hydride? The H minus. H minus is known as hydride. H minus. H minus ion is known as hydride ion. Okay, hydride ion, hydride transfer reaction. Here the hydride transfer reaction is taking place. The name of the reaction is known as Cannizzaro reaction. Okay, Cannizzaro reaction. Cannizzaro reaction. Aldehydes without alpha hydrogen atom. Aldehydes without alpha hydrogen. In the previous class, aldehydes having alpha hydrogen atom we have studied in the previous class, but today class we will study the Cannizzaro reaction. Here the aldehydes without alpha hydrogen atom. What are the examples of aldehydes without alpha hydrogen atom? The formaldehyde, the benzaldehyde, these have no alpha hydrogen atom. Okay, aldehydes without alpha hydrogen atom undergo in the presence of isopropyl oleate, strong base. It is a strong to form the equal amount of corresponding alcohol and carboxylic acid salts. Okay, it will form the alcohol and carboxylic acid salt. One aldehyde acts as hydride. Hydride means H minus. One aldehyde acts as hydride donor, whereas other aldehyde acts as hydride acceptor. Means these are the two aldehyde, formaldehyde. These are two formaldehyde, and one formaldehyde act as hydride donor. It will donate a H minus ion, whereas other aldehyde act as hydride acceptor. This will accept the hydride ion, and this aldehyde will give a hydride ion. Okay, this is the mechanism of reaction. Finally, these are the products formed, and in your books we will study also. Here Cannizzaro reaction is there. Description of Cannizzaro reaction. The Cannizzaro reaction involves, listen carefully. Okay, the Cannizzaro reaction involves the treatment of an aldehyde without alpha hydrogen atom. Without alpha hydrogen atom. This is your without alpha hydrogen atom with concentrated NaOH or KOH. Okay, in the presence of base, strong base, that is NaOH or KOH, the aldehyde undergoes an oxidation reduction reaction. Oxidation reduction reaction. Oxidation and reduction reaction. Reduction means addition of hydrogen, and oxidation means removal of hydrogen. But in this slide we have studied what? Hydride ion, one aldehyde, donate and hydride ion. Donate means that is known as oxidation, and one aldehyde accept and hydride ion, that is known as what? Reduction. Reduction and oxidation reaction. In your Val and Val, oxidation reduction, this is also known as oxidation reduction. Example, when benzaldehyde is heated with concentrated NaOH, a mixture of benzyl alcohol and sodium benzoate is formed. Okay, the benzaldehyde is the example in which there is no alpha hydrogen atom. This is the functional group. This is the CHO aldehyde group, and to the nearest carbon having alpha hydrogen, that is known as alpha hydrogen. But in case of benzaldehyde there is no alpha hydrogen atom. That's why it will undergo oxidation reduction reaction, and the products formed are benzyl alcohol and sodium benzoate. This is the reaction. This is the overall reaction of Cannizzaro reaction. Okay, and what is the mechanism behind it? What is the mechanism? The reaction takes place in 3 steps: step 1, step 2, and step 3. Okay, the Cannizzaro reaction involves 3 steps: step 1, step 2, and step 3. And in step 1, attack of OH minus on the carbonyl carbon. In presence of base, we use sodium hydroxide and potassium hydroxide. It is a strong base. Okay, it will provide the OH minus ion. It will provide the OH minus ion. And that OH minus ion act as a nucleophile. Act as a nucleophile. And it will attack the carbonyl carbon. It will attack the carbonyl carbon. Okay, and this product will be formed. This is the product. This is step 1. And in step 2, hydride ion transfer is there. In step 2, hydride ion transfer is there. This is the hydride ion. This hydrogen ion transfer as hydride ion. This hydrogen ion transfer as hydride ion. Okay, from this hydrogen is transferred as hydride ion, and these are the two products formed in step 2. And in step 3, acid base reaction, only the simple reaction, for example sodium hydroxide and hydrochloric acid. Okay, when an acid and a base will react with each other, a salt and water will be formed, just like your NaOH and HCl. NaOH and HCl. NaOH plus HCl. It is a acid base reaction, that is known as NaCl plus H2O. This is your salt, this is your water, and this is base, this is acid. Okay, this is a very simple reaction. In the step 3, only the acid base reaction takes place. The two products, or these two products act as a reactant in the step 3, and they will react in presence of Na plus ion to form the two products. One is sodium benzoate and another is benzyl alcohol. Sodium salt of acid and another alcohol, benzyl alcohol and sodium benzoate will be formed. This is about the mechanism of Cannizzaro reaction, which involves step 1, step 2 and step 3. Okay, have you clear? Here are the different examples. This is your benzaldehyde, another molecule of benzaldehyde, sodium benzoate, and this is an alcohol. Okay. These are the mechanisms. Transfer reaction, Cannizzaro reaction. Okay, mechanism. Then oxidation reaction. Number 5, that is known as oxidation reaction. Oxidation means addition of oxygen, removal of hydrogen, and loss of electron. This is known as oxidation. In plus 2 level, we have studied oxidation reaction. There is no examples. This page is blank. Then we discuss about electromeric effect. Electromeric effect. What is electromeric effect? It is a temporary effect. It is a temporary effect observed in unsaturated compounds only in presence of some reagents available nearby. Okay, it is a temporary effect. It is not a permanent effect. Okay, it is a temporary effect observed in unsaturated compounds. What do you mean by unsaturated? If carbon-carbon double bond and triple bond are there. Okay, unsaturated compounds only in presence of some reagent available nearby. If at the nearby, or if nearby some reagents are present, then it will affect some temporary effect. It is not a permanent. If the reagent will be removed, the effect will be removed. If the reagent will be present, the effect will be there. That's why it is a temporary effect. Then electromeric effect involves complete transfer of pi electrons of multiple bond. Example, during attack of a carbonyl group, during attack on a carbonyl group by a nucleophile. What is nucleophile? Nucleophile is a negative charge species. Negative charge OH minus is also a or carbanion ion. These are the nucleophile. Okay. During the attack on a carbonyl group by nucleophile, the pi electron pair of C double bond O bond is transferred completely to the oxygen. Okay, and due to greater electronegativity of oxygen and therefore polarize the carbonyl group. This is the carbonyl group C double bond O. Okay, this is carbonyl group C. This is the carbonyl carbon. This is carbonyl oxygen. If we compare the electronegativity of carbon and oxygen, C double bond O. Okay, C double bond O. This is the carbonyl carbon. This is the carbonyl carbon. Okay. If we compare the electronegativity of carbon and oxygen, which is more electronegative? Between carbon and oxygen, which is more electronegative? Oxygen. That's why the electron will shifted to oxygen only. The pi bond will break down. The pi bond will break down, and one bond, Y pi bond, consists of two electrons, and the electron will shifted to the oxygen atom because the oxygen is more electronegative than carbon. Okay, is transferred completely to oxygen due to greater electronegativity of oxygen and therefore polarize the carbonyl group. The carbonyl group will be polarized. The carbonyl group will be polarized means two charges are separated. The carbon is positively charged and the oxygen is negatively charged. Okay, here the delta plus, here the delta minus is there. The positively charged carbon is then attacked by the nucleophile. This is positively charged. Okay, and this carbon will be attacked by a nucleophile. Okay, nucleophile means negative charge species. The negative charge species will easily attack the carbonyl carbon which is positively charged. The complete transfer of shared pair of electron of a multiple bond to the more electronegative atom of the bonded atom due to the requirement of an attacking agent is called electromeric effect. You have to write this definition. What is electromeric effect? The complete transfer of shared pair of electron. One bond, the pi bond means it is a shared pair of electron. Okay? The complete transfer of shared pair of electron of a multiple bond to the more electronegative atom of the bonded atom due to the requirement of an attacking reagent is called electromeric effect. Okay? Here the complete transfer of electron, the pi bond will be break down and the two electrons are completely transferred to the oxygen atom due to oxygen is more electronegative than carbon. Okay, and that is known as electromeric effect. That is known as electromeric effect. Okay. The electromeric effect is of two types, plus E effect and minus E effect. The electromeric effect is two types. One is plus E effect and minus E effect. E tends to electromeric. Minus and plus. Plus and minus. Plus, what is plus E effect? When the transfer of pi electron takes place towards the attacking reagent. Okay. When the transfer of pi electrons takes place towards the attacking reagent means electrophile. That is known as plus E effect. Then minus E effect when the transfer of pi electron takes place away from the attacking reagent. That is nucleophile. Okay, means it is towards the attacking reagent and here takes place away from the attacking reagent. Okay, that is known as nucleophile. It is the electrophile. What happens? This is the carbonyl carbon. This is the oxygen and the nucleophile. Here the nucleophile will attack. The nucleophile is negatively charged species. The nucleophile is negative charged species. And it will attack the carbonyl carbon. It will attack the carbonyl carbon. Do Can you understand? This is, it is very easy. One is plus E effect and another is minus E effect. Plus E means plus electromagnetic effect and minus E means minus electromagnetic effect. This is the nucleophile. This is the nucleophile, and what happens when the transfer of pi electron takes place towards the attacking reagents? Towards the attacking reagents means the electron will transfer towards the attacking reagents. Towards the attack. This is the nucleophile. It is the attacking reagent. No, the electron will transfer towards the nucleophile. That is known as what? Plus E or minus E. That is known as plus E effect. And minus E effect when the transfer of electron takes place away from the attacking reagent. Means if this is the E towards the carbon. Carbon ru jodi nucleophile ko asila tale plus E effect. If from the electrophile the carbon to the carbon the electrons are shifted, that is known as minus E effect. This is the difference between plus E or plus electromagnetic effect and minus electromagnetic effect. Okay. Here that has been described. The diagram has been there. Okay. This is the nucleophile. This is the nucleophile. This is the electrophile. This is the nucleophile. Okay. The nucleophile attack the central carbon. Okay. And the central carbon attack the electrophile. The central carbon or from the pi bond that will attack the. This is the negative charge. Pi bond means the electronegative charge is there. It will attack the electrophile. So it is our plus E effect. This is minus E effect. Okay. Then structure and uses. Different structure and their uses. The first one is formaldehyde. Formaldehyde. Okay, HCHO. You have learned HCHO. This is a very simple aldehyde. This is the simplest form of aldehyde, that is known as HCHO or formaldehyde. What are the different uses? It is used as a general antiseptic. Antiseptic. What is antiseptic? Antiseptic means there are two terms. There are two terms. One is antiseptic and another is disinfectant. Antiseptics are used in case of animals. Okay. And disinfectants are used in case of any surgical items, in case of dishes which have no life. Okay. These are known as disinfectants. But antiseptics are used in case of animals, any type of animal. That may be human beings or any other animals, to kill the bacteria, to make germ free. Antiseptics are used. Okay, during the period of corona, the sanitizer are used to sanitize our hands. Okay, many bacteria are present in our hands. Before going to eating something, we have to sanitize our hand with soaps, with sanitizer, alcohol. Alcohol is used as a sanitizer, and hand washes. Okay. तुम सुबह हाथ धो कि नहीं? मैं इम्तियाज खाई दूँ. Yes. It is used as local anesthetic. Means, what do you mean by local anesthetic? Any one of you? The impulse conduction is blocked. There is blocking of impulse conduction from the localized area. to the central nervous system. Okay, that is known as local anesthetic. The local anesthetic is used for minor surgery, but the general anesthetics are used for major surgery, open heart surgery, any type of organ transplantation. At that time, the general anesthesia are used. Okay, what is the definition of general anesthesia? Reversible loss of consciousness. Reversible loss of consciousness. But what is local anesthetic? It will block the impulse conduction. It will block the impulse conduction from any localized area to the central nervous system. That is known as local anesthetic. What are the examples? What are the different examples of local anesthetic? Lidocaine, xylocaine, lignocaine. Okay. Then number 3, used in preservation of biological specimens. In the preservation processes, it is also formaldehyde is used. It is used in manufacturing of plastics such as bakelite. Okay. Then paraldehyde. This is the structure. This is the structure of paraldehyde. It is a cyclic trimer. It is a cyclic trimer. 3 oxygen are there. Okay, it is a cyclic. This is one monomer, another monomer, and 3 monomers are there, and they are joined with each other by the help of oxygen atom. That's why it is a trimer of acetaldehyde. 3 acetaldehyde are there, 1, 2, 3, and 3 acetaldehyde are linked with each other by the help of oxygen atom. Okay, that's why it is a trimer of acetaldehyde, and it is used as in the manufacturing of resins. It is used in the manufacturing of resins. In the in the pharmacognosy you have studied what is resins. Okay. It is used in central nervous system depressant, sedative and hypnotics. CNS depressant, sedatives and hypnotics. We have already discussed what is sedative and what is hypnotics. Hypnotics means it will induce sleep, resembling natural sleep, and sedatives, it will reduce the anxiety. It will reduce the anxiety. तुमको सब राग आसे कि नहीं, चिड़चिड़ा राग, जदि normal use kariparibा नहीं. In the normal stage, we are the human beings, we have certain degree of anxiety, but if it will be more, then some anti-anxiety drugs are used. Okay. For example, what are the anti-anxiety or sedative hypnotic drugs? What are the examples? Barbiturates, benzodiazepines, benzodiazepine, diazepam, chlordiazepam, nitrazepam. These are the examples of benzodiazepines. It is used as expectorant. What do you mean by expectorant? Do you have any idea? Removal of sputum from the respiratory tract. Cough syrup. Okay. Then acetone. The next structure is known as acetone. This is the very common structure. CH3, C double bond O. What is the uses? It is used as organic solvent. It is used in the synthesis of chloroform. It is used in the synthesis of iodoform. It is used in the preparation of thermo-softening plastic and perspex. Okay. Then chloral hydrate. This is the structure of chloral hydrate. 3 chlorine atoms are there. At the center, the carbon atom is there. To the carbon, the 3 chlorine atoms are attached, and 2 hydroxy group are present. Okay, uses, it is used as anti-insecticide, used as hypnotic, and used in the preparation of DDT, dichloro diphenyl trichloroethane, that is known as DDT. Then hexamine, this is known as hexamine. Okay, this is the structure of hexamine. 6 amine are there. And two nitrogen atoms are not visible. But actually, it is used as a urinary antiseptic. It is used as urinary antiseptic, used as disinfectant. It is used as absorbent for absorbing the poisonous gases. The two terms are there. One is absorbent and another is adsorbent. The adsorbent is a surface phenomenon. Only the surface molecules are saturated with, but absorption is a bulk phenomenon. The total molecules are saturated with. That is known as absorption. Okay? Then hexamine nitrate is used to get explosive cyclonite or RDX. RDX are used. Santraswadi, Pakistan. Okay, they are using RDX for any explosion process. Okay, used in adhesives, coating and sealing compounds. Okay. Then benzaldehyde. Finally, the benzaldehyde. This is the structure of benzaldehyde. This is the structure. This is benzene, and it is an aldehyde. It is used in the manufacturing of cinnamic acid. Okay, cinnamic acid. What is cinnamic acid? Cinnamic acid is an alpha beta unsaturated compound. Okay. Then it is used in the preparation of malachite green dye. Okay, it is used as flavoring agent. It is used as bee repellent. माने महू तुमको कलेक्शन करिवार अछि महू को भगेवार अछि ताले हमें बेंजाल्डिहाइड जदि धुआं सेठी रखि दवा they can remove from that area and we easily collect the honey. Okay. Then vanillin. This is the structure of vanillin. Okay, it is a very complex structure. This is an aldehyde. OCH3. Okay, here OH is there. It is used as flavoring agent in ice creams and chocolates. Vanilla flavor. Okay. Then it is used in perfume industry. It is used to mask the unpleasant taste and medicines. Okay. In the pharmaceutics, you have studied. What? Flavoring agent. What is flavoring agent? What is the definition of flavoring agent? Do you know? To mask the unpleasant flavor. To mask the unpleasant flavor, the flavoring agents are used. Maximum medicines have unpleasant flavor. They are vomiting, they will induce vomiting or nausea, and they are also bitter in taste. There are also many antibiotics, the chloroquine, anti-malarial antibiotics, and maximum allopathic drugs or synthesized drugs are bitter in taste and very unpleasant in smell. Okay, to mask the unpleasant smell and bitter taste, we have to use the sweetening and flavoring agents. Okay. Then what are the doubts? Do you have any doubt? What are the other reactions we have studied? Oxidation reaction, any type of oxidation reaction. Oxidation reaction is in your syllabus or not? Oxidation reaction is there. Oxidation reaction here. The oxidation reaction is there. Aldehyde is readily oxidized to benzoic acid. Benzaldehyde oxidation means, I have told you before, the alcohol is oxidized to aldehyde, aldehyde is oxidized to acid. Okay, it is a very common type of reaction. Then oxidation reaction of benzaldehyde. Benzaldehyde is readily oxidized to benzoic acid by a number of oxidizing agents. Example, acidic potassium dichromate and acidic potassium permanganate. Okay. Permanganate or dilute nitric acid. This is your benzaldehyde. This is your benzaldehyde. It will be oxidized to benzoic acid. Okay. The benzaldehyde is oxidized to benzoic acid in the presence of oxidizing agent like K2Cr2O7, potassium dichromate, and H2SO4. Then benzaldehyde also undergo oxidation with Tollens reagent. Tollens reagent. What is Tollens reagent? Ammoniacal silver nitrate solution. What is Tollens reagent? Who can tell? A Fehling solution, Tollens reagent. These are important. The Tollens reagent is ammoniacal silver nitrate solution. Ammoniacal silver nitrate solution to give the ammonium benzoate and silver mirror. Okay. Ammoniacal silver nitrate solution is known as Tollens reagent. Benzaldehyde undergo oxidation reaction with Tollens reagent. Okay. Okay. One for